This video is going to show you how to apply the law of conservation of energy to a word problem. So here's a little animation of the word problem. I'm at an amusement park and I've got this ride that goes over the hill at location A and slides down to location C. There's no friction or any other outside forces between location A and location C. The question is, what is the velocity at the bottom of the ramp at location C? The first thing I need to do is state which concepts I'm using to solve this problem. So I'm using conservation of energy concepts, so I'll start out with this expression. Sum of all the energy at location A equals the sum of all the energy at location C. So that's what it's saying mathematically, and I translate it into words. And then I gotta look at the energies. At location A, there's kinetic energy and potential energy. At location C, there's kinetic energy and potential energy. So to help convey that to whoever's reading this, I wrote Ke plus Pe to indicate those are the energies I'm looking at, and then Ke plus Pe at location C, because those are the energies I'm looking at. Now in terms of locations, everything on the left-hand side of the equal sign comes from one location. Everything on the right-hand side comes from the other location. So in other words, for the left-hand side, I'm looking for the kinetic energy at A and the potential energy at A. And on the right-hand side, I'm looking for the kinetic energy and the potential energy at C. The next step is to put in my formulas for kinetic energy and potential energy. But before I do that, I've got to figure out which of these energies is going to be equal to 0. So to do that, I'm going to ask some simple questions. I'm going to ask at location A, is it moving? If it is moving at location A, I'll keep that kinetic energy. Then I'm going to look at location A and ask, is it above the height of the other object? And if it is above the height of the other location, not object, if it's above the height of the location, then I'll keep that potential energy. In this case, both those answers are yes. Then I'll look at location C on this right-hand side of the equality, and I'll ask, well, is it moving at location C? And sure enough, I can even see from the animation it's moving at location C, as I would expect when it goes downhill. So I'll keep that expression. Is it above the height of the other location? And that answer is no. So whenever I answer no, I'll get rid of that energy. So in this case, it's going to be potential energy, and I'll just mark that with a little line and arrow and a 0. So I know that's going to go away. And this helps me to write the formula. So for each of these problems, you're going to write your own formula based upon the physical situation and asking these simple questions. Is it moving at this location? Is it above the other position's height? If you answer yes to those questions, then you keep that energy. If you answer no, you get rid of that energy. So now I've got my expression set up. I'm creating my own equation. I'll substitute in 1/2 mv squared for the kinetic energy, mgh for the potential energy, and then on the right hand side 1/2 mv squared. Now it might be tempting just to say, well, I've got 1/2 mv squared on both sides of the equation, they'll go away. But they're not going to go away, because you've got to remember the numbers that go in, the velocity and the height, on the left hand side of the equal sign come from location A, and they're going to be different numbers in different numbers in location C than they were in location A. Next up, I can see mathematically that I've got an m in all my expressions. Since there's an m in every one of those expressions, that's going to divide out. So I don't even need to know the mass of the cart. 1/2 v squared plus gh at location A equals 1/2 v squared at location C. Now I'm going to plug in my numbers, and again I'll emphasize to you that on the left hand side those numbers come from location A. On the right hand side, if I had any other numbers, they'd come from location C. So the left hand side, I know that location A I'm moving at 5 meters per second, and I also know that I'm 11 meters above the lowest height. On the right hand side where C is, well, that's what I'm looking for, and that's the unknown velocity. Do a little bit of math, and I get my final answer, 15.5 meters per second. So the cart starts at 5 meters per second, slides down the hill, and speeds up to 15.5 meters per second. And based upon my experiences, that answer makes sense. When I do coast downhill on a bicycle or in a car, I do speed up, so that sounds like a good answer, 15.5 meters per second.